There we go. All right. So we're going to start with a few logistical things. So first off, the way I'm going to run this is there's going to be an hour of instruction and exercises. So that's me talking about some stuff and then having y'all complete some polls or do some exercises on your own, and then have various ways of getting information back to me. So we're going to be using Zoom polls, and then some of the stuff I'll have you paste stuff into the chat just so we can see if you're getting the right answers back. So I'm the primary instructor, but I do have several helpers here. You can find them under the participants. They have helper after their name. They're basically my seconds in command. The idea being that if you have a question that involves some sort of weird troubleshooting thing that's going wrong for you, it's probably best to ask them through the chat. So just post to the chat something like, my thing crashed, or I keep getting this weird error, or I can't manage to get this thing to happen. Let them know. If you have a question about understanding, like I don't quite understand what you mean by this, go ahead and unmute and ask the question, because probably if you're confused about something, someone else is also confused about something. I also appreciate the feedback. So I'm doing 2 of these per week, and on Tuesday I realized that talking to a screen for an hour doesn't work very well for me. So I like having feedback, and if there's any time that you are confused or have questions, go ahead and unmute. And the plan is that the last half hour or so of this, whenever we finish, will be set aside just for Q&A, just time to stop the recording and let people ask whatever they want to ask. Let's see. So one more thing is that by being here, you agree to abide by the Carpentry's Code of Conduct, which you can find by just Google searching it. We're not going to read the whole thing because it's a long semi-legal thing, but basically the idea is be a nice person to people. It's summed up in these 5 statements, which I am going to go through. Be welcoming and use inclusive language, be respectful of different viewpoints and experiences, gracefully accept constructive criticism, focus on what is best for the community, and show courtesy and respect towards other community members. So by being in this webinar, you agree to abide by these rules, these guidelines. I would hope you would do so anyway, because these are just sort of basic human decency and how to treat other people. But if anyone does violate this, then I will have to kick you out of the webinar, which will make both of us sad. So please don't do that. All right, so any questions on this sort of logistical setup? What we got here on carpentries, anything like that? Okay, then let's get started. So I asked everyone in the email to please pre-install R and RStudio. And the reason why I chose RStudio is because it's the most common way that people interact with R. So R itself is its own thing that does programming, essentially. It's an interpreter. You give R instructions, it parses those instructions from human readable stuff into a bunch of 1s and 0s that it can then send on to the processor. The processor does its thing, spits back an answer in 1s and 0s, and then R retranslates that back into something that we can understand. Basic R, that's what its job is. It's an interpreter. It's not particularly user-friendly, and so people have built up various tools to make it easier to use R, and RStudio is the most popular one of that. So that's why I ask people to use that. It is, whenever I have students, 90–95% of them are using RStudio just because it makes things so much easier. So you can follow along. I realize that trying to watch what's on my screen and also do stuff on your screen can be challenging. I understand. We have exercises and stuff that will have me taking a break from stuff. So if you just want to watch for now, that's fine. If you want to try to follow along, you can also do that. So first off, we're going to open up RStudio. RStudio basically wraps R. It has R going in the background and then a bunch of stuff in front of that to make your life easier. And once this gets loaded up, I will talk about what some of those things are. Come on, computer. People are waiting. All right, so when this opens up, it should have 3 or 4 windows open. And when you open yours, it usually defaults to 3 or 4. depending on if you've been working it previously. A fresh install will usually have 3, like here. So here on the left, we have the console. This is the actual interface to R. Just a moment. Apparently my computer's having issues. Give it a moment to catch up with us. So on the left-hand side is the console. This is the actual interface with R. So we have this little caret down here, this greater than sign. That's where we actually give our instructions. This information up here, this is just some background info. It's generally not very important, although the one where it tells you the R version, so I'm running 4.0.2, that can be important if something goes wrong, because R is updated every few months. Knowing which version number you have might be important to figuring out what's going wrong. So that's important. The rest of this is generally ignored. On the right-hand side, in the upper part, you have like the environment tab. It also has ones for history and connections and a tutorial. The environment gives you a glimpse of what's going on in R right now. We're not going to use it right now. And these tabs generally I find less useful. The ones down here on the bottom, however, the bottom right, tend to be very useful. Here we have files, which is a bit of a file browser. Plots are where any graphics you make pop up. We'll talk about packages later. These are basically plugins for R that let it do more things. The help is where you find help. And then I actually don't know what the viewer does because I never use it. So, but these other ones tend to be very frequently used. And then the last one only shows up when you make what's called a script. So if you go up to File and do a new file, and specifically an R script, it'll pop up a new section up here in the upper left. This is the script. Scripts are very important. Down here in the console on the lower left, if we type something and we run it by hitting enter, then R will run it and it will be up there for as long as we keep RStudio open. But as soon as we close RStudio, it goes away. It's lost to the ether, can't get it back. Whereas up here in the script, this is a file on the hard drive. So I will go ahead and save this one now. So I will do File, Save As, and I'm going to save mine on the desktop as just testscript.r. R scripts usually have the .r postfix just to make it easier to see what they are. So testscript.r, save. Now anything I type up in here, I can save and it will exist on my hard drive. So I can close on RStudio, I can come back a week later or a month later, it's still there. I have a record of what I did. This is very important. So you can use the console down here for some quick checks to try to troubleshoot or figure things out. But anything you want to actually be a real analysis you want to keep, you want to have that written in a script. And there's a very simple reason for that. You won't remember everything you did when it comes time to do it again or to go write the paper or anything like that. Some of these analyses can get very complex. And you need a record of that so that when you come back 2 weeks, 2 months, a year or two later, and you need to write the manuscript or share with a colleague, you can actually see what you did. And so that's why I encourage, as we go through this, to keep a script up here. So now, time for the first exercise. I'm going to give you all a few minutes. I want everyone to open up RStudio. I want you to create a new script by using the file, new R script, and I want you to save it somewhere on your computer. Doesn't really matter where. If some of you are on phones, I understand you won't be able to do that. But anyone who's actually on a computer, please do this. I'm going to give you a few minutes. And what I want you to do is if you open up the Participants tab, there are some little icons down at the bottom, like a yes, a no, go slower, go faster, whatever. When you have finished that, when you have saved your script, click the little yes badge, and it'll put a check mark next to your name, and I can use that to gauge how far along everyone is. Okay? All right, everyone go. Start up RStudio, make a new script, and save it somewhere to your hard drive. I guess helpers, if you can go ahead and click the little check mark or whatever too, that just helped me see the overall progress. I know you guys can probably do that. All right, looks like we've got a mix of some people coming in from phones where they're just typing done. Okay, so I'll give everyone about 30 more seconds to finish this up and then we'll move on. Okay, so you've got your first script out. And actually, before we go further, I want to check something. So I'm going to be sending everyone a poll. I want to know what your experience level with R is. So you should see a poll launch up that asks you to choose your experience level. Go ahead and put that in. And once I've got everyone in, then I'll share so you can see what we've got in the room. I'm expecting mostly beginners in this course because that's what this is aimed for. Okay, so I believe that is just about everyone. I'm sorry if I'm cutting you off. So this is our distribution. So it looks like, yeah, we have about an even spread of on the novice side of things, which is exactly what I was expecting. That's what this course is aimed for, so it's good to see. And so in here, as we go through this course, I want to specify what we're going to be doing, especially today. Today is the very foundational nuts and bolts. We will not get to anything too exciting today. I'm just full disclosure. It's like what you find today will probably not be directly relevant to specific projects you have or anything. These are the nuts and bolts. This is like how you have to learn letters before you can write poetry, or you have to learn individual notes before you can play a song. Today we're going to be talking about these individual concepts that in later lectures we will then be putting together in more complex ways to show you what you can do. We've got to start somewhere. All right, let me close this down and move on to R itself. So R can do a bunch of things. One of the most basic things it does is math. So you can actually use R as a calculator. Most people have an actual calculator app on their phone or whatever they prefer, or a physical calculator, but you can use it as a calculator. This itself is generally not too useful, but it becomes very useful as you start using the same functions on your data. So being able to add two numbers isn't very impressive, but when you start adding variables together or taking square roots or means or averages, that starts becoming more important. We're going to start with numbers though, because they're simple and easy. So math can do all, or R can do all basic math functions. So I'm going to type up here in the script area, 5 plus 7, and then to run it in R, I'm just going to click the run button, and that will run the line that I am on. If I want to, I could also just highlight it and press run. Or if you like keyboard shortcuts, at least on the Windows, it's Control Enter will do it. I think it's Option Enter on a Mac. There are keyboard shortcuts, but easiest way is you just press run on that. You notice how it copies the line down here to the console, and this is what gets sent to R to interpret to send to the processor. R translates 5 plus 7 into a string of binary code. That goes to the CPU. The CPU says, oh, I need to take these two things and add them together. It comes up with a new string of binary code that's the result, feeds that back to R, which R translates back into the number 12. And for right now, there's a little 1 in brackets to the left of that. Ignore that. We will talk about it in a few minutes, but for right now, ignore it. It's just our answer here is 12. We can also do multiplication. 8 times 4 is 32. Division, subtraction, fine. More interesting ones are things like exponents. 5 up caret 3. 5 cubed is 125. There are functions that can get you more complex things like square roots. So SQRT is the square root function. And all functions have parentheses after them, and we will talk about this more probably next week about what a function is. But suffice to say, it's a name, 2 parentheses, and then you put in between those parentheses what you want the square root of. So the square root of 149 is 12.20656. We can do, say, we want to round 57.621, and round that, rounds to 58. So these are various functions, various utility you can do. One note in terms of numbers, because R is meant to do statistics and science a lot, it makes scientific notation very easy. So you know how on science we often do like 6.58 times 10 to the 23rd. Actually, that's a really big number. That will be hard to say. Let's 10 to the 6th. So this is one way of writing out basically 6.58 million. Because things like this, where powers of 10 are very common in science, R makes it easy to do that. Another way of writing this line would be 6.58 E6, where this lowercase e just means times 10 to the power of whatever comes next. So this is 6.58 times 10 to the 6th. And if I run that, we get the same thing out. We could do 5.7 e negative 4. 5.7 times 10 to the negative 4th, 0.00057. And so this makes very big and very small numbers easy to work with. So now we're going to do another exercise. In R, I want you to find the square root of, let's see here, 18 million. You can do that however you want, but find one way or another, find the square root of 18 million, and when you have it, paste that number into the chat. Go. I'll do another 10 or 15 seconds for anyone catching up. I think we've just about got everyone. All right. So looks like everyone who got it got the same answer, 4,242.641. Now there's various ways we could do this. So this could be the square root of, was it 18e6, square root of 1.8 e7, could then the square root of 18 million. You could even have done 18e6 to the 0.5 power, which, if you remember algebra, is how you do a square root in exponential notation. If we run all these, you see that all of them come up with the exact same answer.
Oh.
And so there's an important lesson here. Anything you can do in R, there's probably more than one way to do it. This is common in all sorts of programming languages. There's almost always multiple ways of doing something. Now that said, sometimes they're a lot easier to understand than others. Like of these ones up here, I would say the first one is probably the clearest. It's the square root of 18 times 10 to the 6th. These other ones are okay, although my eyes start going a little blurry as I try to count zeros and such. So you can do things in more than one way. There's not one single correct way. But do try to pick the one that is easiest for others to understand. All right, one more thing here is we're going to do order operations. quick aside. So you notice I'm typing words here with this little hashtag in front. That's called a comment. R ignores anything that comes after a hashtag in a line. So I can run this, nothing happens.
Nothing.
I can do, if I do this.
It's notes for yourself.
Let's see, just a sec. Yeah, I can put a comment here of on the exponential. If I run that, R ignores it. R ignores anything that comes after the hashtag because it's built into the language that that's for a human. Anything that comes after a hashtag is a comment that you put there to help other human beings understand what is going on in your code. So I titled this section, Finding the Square Root of 18 million. This one's Order of Operations. This helps me understand what's going on in this section. And we're going to be using these more as we go through and develop more complex codes. You'll see me using them a lot to help keep things organized. And so I highly recommend you get in that habit. Oh, I also highly recommend you get in the habit of saving frequently so that you don't lose your work as you're going. So order of operations. This is the exact same as you learned in high school algebra, where multiplication takes precedence over addition, and exponents take precedence over both of those. So if we run this, 605, that's because the first thing here is the exponent, 10 squares, that's 100. The next thing that has precedence is
100.
the multiplication, so that's 600 plus, and then 5 plus 600. If we take this and we add 15 on the end, then again, order of operation happens, then we end up with 5 plus 600 plus 15, ultimately. So this is no big change. You can use parentheses the same way. So if I want to change this, something say, no, it's 10 to the 2 plus 15, the parentheses take precedence. And so now we get a very different answer. 5 plus 6 times 10 to the 17th, which you'll notice it sort of, because of scientific stuff, it rounds it off at 6E17. So technically, this is not exactly correct. It's 6E17 plus 5. But by and large, when you use exponential notation like this, you don't care about things to the 15th decimal place. You only care about the first few. And so R does that as well. It only gives you the first few decimal places. So it is poll time. We're going to see how well people remember their order of operations. So there are two questions here you're going to be getting. One is just asking about general output, and then the other is seeing which thing evaluates to 23. So go through this. When you get the answer, just submit it. And when I've got what looked like everyone in, I'll share the results and we'll see how people did. All right, so it looks like we have about half of the learners have responded. I'm going to give you another 20 seconds and then we'll call it. Okay, let me share these results. All right, so on the first question, y'all did very well. It says relatively simple one. Everyone got the correct answer of 43. So 5 times 3 plus 14 times 2, order of operations simplifies that to 15 plus 28 is 43. That's relatively simple. The next question was a bit more challenging. So which of the following evaluate to 23? And there's those 5 different choices there. Well, the fact is all of them evaluate to 23. This is again a case where you can do one thing in multiple ways. So we have no parentheses, some parentheses, lots of parentheses. We have scientific notation, we've got a square root in there. All of them actually work out to be the same. Now again, this is a lesson because just because they all work out to be the same, some of them are much easier to understand than others. If I had to choose one, I would choose the second one, where it just has one single set of parentheses, and that's just sort of a reminder that exponents take precedence. It's not necessary, but it would help me remember that because that's something I might forget while I was just glancing through the code. So again, more than one way to do stuff. Try to choose the one that is the easiest for other people to understand, especially because the other people that need to understand it, half the time is you coming back a few months later and you have no idea what you were thinking at the time. So when you write good code and you write clear code, it makes it easier for you and it makes it easier for other people. All right, so that's basic math. Now, just using R as a calculator is pretty underwhelming. The real power comes from using variables. So most things in R are either a variable or they're a function. We've talked a little bit about functions, like this square root thing. Functions do things. Functions, you give them some sort of information, some sort of data, they do something with it, and then they give you something new back. So like the square root here takes a number, calculates the square root, and then gives you that value back. The mean takes a collection of numbers, finds the mean value, gives you that number back. Plotting stuff that we'll get into in a few weeks takes some commands, makes a graphical plot, and returns that for you. Functions do things. What we're going to talk about now are variables. Variables store information, and they're very useful because they let you keep information around and do stuff with it. So first thing you have to understand about variables is that they have names. So up here we were all working with numbers, but variables get names. So variables have a few rules. Just a second. So the naming rules are that, I just cannot type today. They can be any alphanumeric. So that's any letter, any number, uppercase or lowercase. It can be underscores or periods. So that's that or that. And must start with a letter. So you can't start with a number, you can't start with an underscore. Technically speaking, you can start with a period, but you shouldn't because that actually creates what's called a hidden variable, and that will just make your life more difficult. So don't do it. Start variable names with letters. You can use any sort of letter or number, underscore or period. So valid variable names are things like X and Y. I don't recommend those most of the time because they don't give you any information about what they contain. Unless you're like doing a graph, in which case it's the X and Y values, that works. But more useful ones are things like height or scores or min level or max value storage. These are all valid variables. One thing to keep in mind with R is that case matters. So max.value like that is not the same as max.value where it's all lowercase. So if you have capital letters and lowercase letters, a variable that uses capitals is different from a variable that uses lowercase. To R, these are completely different things. And so you need to make sure you have your naming correct because oftentimes, if you create a typo, R will cause a problem. And I'll show you some examples of that in a moment. First, we need to show what we do with variables. We assign them. I said variables store information. The way you get information into a variable is you assign it. Use an assignment operator. And there are two different operators in R that work as assignments. The one that you see most common is this arrow right here. So it's a less than sign and then a hyphen. And this says take the value of 5 and put it in a variable called x. And so now I'm going to run this, and you'll see a few things. First off, this puts it in x, and it doesn't print anything out. That's because nothing got sent back. So it just says, okay, I'm going to store this value in x. And then you see up here in the environment tab, I suddenly have a variable x whose value is 5. This is where the environment tab is useful. It lets you see what variables you have and what their values are. The other assignment operator is the equal sign. In this case, we're going to say y equals 15. Again, we run it, no printout down here in the console, but we now have the variable y as 15, which means we can then say, okay, what is y? I'm just going to type y. Y is 15. X is 5. And so now these are variables that store this information. What's really going on is that behind the scenes, R has carved out a piece of your computer's memory and put the number 5 there. And then it has a little arrow, it basically has a label attached saying this is X. Anytime the user says X, it means this part of memory which currently holds the number 5. Anytime it says Y, it's this other part of memory that currently holds the number 15. Variables can hold very complicated bits of information. These ones here are holding a single value, a single number. In a little bit, we're going to show how they can hold multiple values. When we get to more complex things like plots, they can actually hold hundreds of different things that are all used as instructions. So variables can hold a lot of stuff, but ultimately they're handles. They say there's a piece of data I care about, and I'm going to use this name to refer to that data. And that's how R can help manipulate that. And the reason that this is useful is because you can then do things with this. So we've assigned values to these. Now we can say, well, x squared is what? It's 25, because that's equal 5. If we do z equals x times y, and we run that, again, we now have a new value z. We can see up here in the environment tab it's equal to 75, but if we want to double check that in the console, we type 75. And so now we can start using these labels to manipulate the data. Again, not too complicated when you have one piece of data. Oh, just a sec. Clicked off the console tab. When you have one value. But as we start getting into more and more complicated stuff being stored in variables, this becomes much more useful. And then I guess one more note up here on these assignment operators. As I go through this, you will see I usually use the equal sign. That's because that's more like other programming languages. And it's also one keystroke instead of 3, so it's less likely I'm going to mess it up. That said, if you look in R's documentation or online, just for historical reasons, the arrow symbol tends to be more common. And so you'll see both of those. Just want you to understand they're equivalent. They mean the same thing. So we're going to do an exercise right now. I want you to do this. I want you to make a variable. Let's call it score, and give it the value of 67. Then I want you to take that variable, take its square root, multiply by 10, and store that in a new variable. And let's call that like score.adjusted. Then I want you to print the value in score.adjusted to the console. That does by just typing the name on the console. So this is taking variables, it's running some data through it, it's doing some manipulations. This is actually the square root curve my high school biology teacher used. This is how he would curve his tests. So this, now we're starting to get into some actual useful applications. So anyway, go ahead and do this. Make your variable, store the value, take the square root, multiply by 10, and store that in a new variable, and then print that value to the console. And yeah, when you're done, either send done to the chat or click the little little yes next to your name in the participants tab. Guess. There we go. I'll do another 20 or 30 seconds. Looks like most people are done. Okay, so if anyone didn't get, what you should have is something vaguely like this. So score equals 67. We're going to take the square root 67 times 10, and then do that in a new variable. So score.adjusted equals square root of 67 times 10. And then to print that out, we use that variable by itself. There's no assignment operator here, so there's nothing to save the value into, so R just prints it on the screen. So if I go and I run this, we get adjusted scores 81.853, whatever. So that is how you go about using variables as handles on data. Now, there's a very interesting thing in here that is different from algebra. Most of this so far is basic algebra stuff. But you can update variables. And this means that you can actually use a variable to change its own value. So here I've typed x equals x plus 1. If you were to look at this in high school algebra, this is an impossible thing. Like, something cannot equal 1 plus itself. However, in R, what happens under the hood is actually R sees this assignment operator, this equal sign. It says, okay, I'm going to look to the right-hand side of that, and I'm going to evaluate all of that information and figure out what that means, and then I'm going to assign that to whatever's on the left. So I don't remember what x was. I'm going to check it out. X is 5 currently. So if I run this, let's keep track up here in the environment area. So x equals x plus 1. I run that. X is now equal to 6. What R did, it said, okay, x is, here we have an assignment operator. So on the right-hand side, we have x. Well, if I look up in memory, x is 5. 5 plus 1 is 6. So I'm going to assign the value of 6 to x. And so it carves out a new slice of memory, puts number 6 in it, and then assigns the label of x there. Since we had x elsewhere, that previous one is gone. The previous label on the value 5 is just lost to the ether. It is gone. We cannot get it back now because we have changed where the label is. And so we can keep doing this. We can just run that again and again and again. You see, every single time, the value x keeps ticking up by 1. And so you can use a variable to update itself. This helps. This is sort of like an economy of variables. So you don't have to make a new variable for every single step of your process. If you have a complex operation where you need to do 5 or 6 things to your variable, you can do them all and keep reusing the same variable name to the end. Now, this can go overboard. You don't want to have 2 variables in a 300-line script because at that point, who knows what they're worth at any single point. This is one where you try to make it make sense. So if you only ever, if the variable keeps using the same function in your code, if it's the same thing, so for example, if I'm just adjusting the score and there's just 3 or 4 steps to that, it makes sense to keep the same variable name to adjust the score. But if I then start doing something else that is completely different, then it makes sense to make a new variable name to keep it clear. And these things will make more sense as we start making more complex programs ourselves. So that's updating variables. And before we go on to the next one, it's poll time. So just to sort of review what we have been doing so far on variable names and on assignment. So you should be getting a poll right now that asks you to fill out which of the following are valid R variable names, and then which of the various assignments will actually make the variable height have a value of 15. So please fill those out. When you're done, submit them, and then we'll see how people do. All right, another 15 seconds. Okay, let me share these. All right, so variable names. So of this list, looks like people have done pretty good on this. The first two are both valid variable names. Min underscore height and max period height are both valid names. They obey all the rules. Looks like most people got that underscore age is not a valid name. You can't start a variable with an underscore. Dot mass, while technically is valid, you shouldn't do. So having most people avoid that is actually probably the right answer, because using variable names like that will make your life more complicated. Max length, where you just got some capitals thrown in, also fine. Min minus length, this looks like it's a tricky one where about half the people said yes. This is not valid. The minus sign cannot be part of a variable name. What R thinks you're doing here is saying, I want you to take the value in min and subtract the value in length. So this is not a variable name, this is an operation. This is math as far as R is concerned. Two widths, also not correct because you cannot start with a number. It has to start with a letter. Celsius to Kelvin, however, is fine because the number is in the middle. So overall, pretty good on those. And then it looks like most people got the correct value for the assignment. We had people select the left-hand arrow and then the equal sign. And those are both the correct ways of doing assignments. So good work. Do we have any questions up until now, conceptual ones or things where people aren't clear? Okay, I'll take that as a no. All right, so one more thing we're going to talk about with variables today, and that is variables with multiple values. We'll talk about how to make these. There's all sorts of ways of doing this. We are going to talk about the simplest single one today, mostly just to demonstrate variables can have more than one value. And the way we do that is with an operator that is the colon operator. And what this is if you have two numbers separated by a colon, what R will do is it will make a sequence of numbers starting at the first and going to the second. So 5 colon 14 generates a sequence of numbers 5, 6, 7, 8, 9, 10, all the way up to 14. If we do 47 to 252, same thing. Now we have a lot of stuff. And you remember that the numbers in the brackets I mentioned earlier, now they come into useful. These are indexes. So the index tells you where you are in one of these sequences of numbers. So this one is just showing you that the first value on this line is 47, and then it has a bunch of other stuff. And then the second line, this value 61, that is the 15th value. and 75 is the 29th value. That's what these numbers mean. Like I said, variables can store multiple things, so we can just set this to a variable. Let's call it range, and that will now store that value. So if we look at range down here in the console, it is the numbers 47 to 252. So this is where we can start storing multiple values. We will get into how to load in things like test scores or phenotype values or other things where you can store an entire list of information in a single variable. What is very nice about this is not only can you keep everything in a single variable, you can actually pull out specific parts of it. So just like the numbers here in brackets mean this number 117 is the 71st value, I can use square brackets right after the variable name and give it a number, and that will pull out that specific number. So the 71st value is 117. If I pull out the 250th value, that is not applicable because this thing is actually not 250 long, so there's nothing there. If I reduce this, however, down to say 150, now there's a value there. So the 150th value is 196. So this way you can pull it out. You can actually even use the colon operator to pull out a range of stuff. So let's say we want the 4th through the 11th values. We do 4:11, and that will pull out the 4th through the 11th values into a new vector. So this is a vector is the name of these sequences of numbers. And so now we have a new one where you can see its first value is 50 and the second is 51. So this is a new thing. You can go a little crazy with this. So let's say we want to take the 4th through 11th of range, and of that we want the 2nd through the 5th, and then we want the 1st through the 3rd, and then we want the 2nd of that. This is valid. I don't know why you'd ever want to do something like this convoluted, but it is valid, and this can be useful when you've sometimes in more complex things you have variables holding very complicated data. You probably won't need to do this, but I pointed out to show that it's something you can do because it means that each one of these is pulling out and making a new thing. So we could do, let's call it x1 equals range 4 to 11. That's that. Then x2 equals x1 2 to 5. Get that. And so you see how I could unpack this and do this with separate variables as well, and we eventually arrive at the exact same thing. This is far more common and far more readable. So I recommend if you need to start digging in, you use this method instead. But if you get more comfortable with R, you're able to stack more things on top of each other while still being able to understand it and make it clear for other people, then you can start doing this. I wouldn't recommend 4, maybe 2. It's like something where you've got 2 brackets in this, it maybe could be useful. Anyway, so that's how you can use multiple values. And this is where things start getting useful, because you can do operations on them. So let's go back here. Our sample is 5 to 21. New variable, new values. If we look at them down here, sample is just the values 5 to 21. But now we can start doing things. We can add numbers to these. Sample plus 10. And now that will add 10 to every value in sample. We can take the square root of sample, and that will get the square root of every single value in there. You can even multiply these things. Sample times, I don't know, times 5. Predictably, it will just multiply by 5. One important thing, though, is if you do times, I don't know, let's do range. If you multiply 2 of these variables together, they do not do matrix multiplication or vector multiplication like you may have learned in algebra. They just line up the numbers and they multiply them together. And if one is shorter than the other, it will actually just start back at the beginning and keep going until it manages to make them both fit, which is sometimes not what you want. And so that's why it actually gives this warning message, is that the longer object is not a multiple of the shorter object. It means it can't keep recycling the shorter one and then have it work out evenly, which means you might have done something wrong. If you ever see this warning come up, you're probably multiplying two of these vector variables together, and you probably shouldn't be. It's probably not what you mean. So anyway, this is how we can use these groups of values and do operations on them. This is one of the things that sets R apart from most other programming languages, like Python or Perl or C or Java or something. Most of them, your very basic variables can only store one thing at a time. It takes more complicated things to store multiple values at once. Because R has always been a statistical language and statistics deals with collections of numbers, R makes it so that everything pretty much works on collections of numbers instead of individual numbers. This makes it convenient for doing stats, but it can sometimes be a little hard to wrap your head around. So thinking in vectors, like thinking like R thinks, where everything is a collection of numbers, can be a little tricky and sometimes takes a while to get comfortable with. So don't worry, the more you practice with it, the more comfortable it will become. So questions on this right now?
Hi, Jason.
Yeah.
I had one potential question, which is, for instance, if somebody's familiar with Python, for the range, when you want to select just that first number or the first value in a vector, whether you use 1 or do you use 0?
Okay, that's a good point. All right, so if any of you are brand new to computer languages, then that question may not make sense. But for some of you who may have worked in a different language before, like Python or Java or something, most languages start counting from 0, where the first value in a collection is the 0th value, the second one is the first value, etc. There's reasons for that, which we don't need to go into. The important part for this is that R is not like that. R starts counting from 1, which is more intuitive to people who are new to this, where the first value is at position 1. If we try to do it with position 0, we get an error. There's nothing there. It's not really an error. It says that it's telling you that it's returning something that doesn't exist, basically. And so if you're familiar with other languages, you do have to keep in mind that R counts differently. If you have never worked on another computer language and you haven't gotten to that habit, then don't worry about it. R counts from 1, makes easy sense. Other questions? Okay, so we are going to do an exercise now. And this is going to be, again, starting to use these manipulations. What I want you to do is make a variable with the values from 15 to 147. Then I want you to take those, cube those values, and save it to a new variable. Then I want you to find the mean and standard deviation of those values using the mean and SD functions. And when you have that, paste them into chat. Don't worry labeling which is the mean and which is the standard deviation. It should be fairly obvious. Okay, everyone go and put in chat when you're done.
Hey, Jason,
Yes?
what does cube mean?
Oh,
Lines.
that means raised to the third power. So
Oh,
2 cubed is
okay.
8, for example. That's 2
Oh,
times 2 times 2.
okay.
Sorry.
Thank you. When I tried it, when I put the like the cube to 3 and z equals parenthesis c cubed to the 3, it tells me that non-numerical argument to binary operator is an error.
Okay, we may have to troubleshoot that later to figure out exactly what's going on. So keep that in mind. We can talk about that in the open Q&A at the end. Because it
When
would
I
be hard
try,
to diagnose that without being able
when
to
I try the mean parenthesis c, giving the range, c equals 15 semicolon 147. When I say mean parenthesis c, it also gives the same, exactly the same error, the same warning message.
Okay, we'll troubleshoot that later at the end when I can see your screen, okay?
Okay. Thanks.
No problem. All right, we'll do about 1 more minute, and then we've got to move on. Okay, so you should have ended up with something that looks mostly like this. Looks like most people are getting the same answers, so it seems like most people got it. Let's just say this is our values are 15 to 147. Then new variables cubes is values cubed. And then I'm going to find the mean of cubes and the standard deviation of cubes. So if I take all of these and run them, we get that the mean value of cubes is 889,000 and change, and then the standard deviation is 919,000 and change. So here we've, again, taken a range of values, so a collection of multiple values. We've performed an operation on one of those, and then we've found some sort of information on it. And this is really what the heart of what you do in R is you take information, use functions to manipulate that information, and then you get something new out. I mean, really, although it's not just means and standard deviations, even something as complicated as like an RNA-seq experiment, where you're measuring gene expression on thousands or tens of thousands of genes across dozens of data points, is basically doing stuff like this. You load data in, you store that data in variables, you use functions to do stuff to that data, and you get new information out that you can then use. So that's the basics of it. Questions on this so far? Okay, so that's what we're going to do about variables today. We have 2 quick things to go over, which are more how to work with R. I mentioned at the beginning this packages tab. R packages are basically plugins. They are very useful because they bring additional functionality to what R can do for you. So the basic R functions, like the R that you get by default that's installed, has a lot of useful stuff. It has means and standard deviations. It can do linear regression. basic plotting and such. But oftentimes there's specialized or more advanced techniques you want that are not part of the basic R. Rather than having you install hundreds of thousands or millions of things you might never use, what R instead does, it installs the minimum, the most common things, and then people have these packages that they can use to install other stuff. And you'll oftentimes find these either by doing Google searches for trying to do what you want to do, or by reading what people use in papers for their own analyses. So the easy way to install these is to use RStudio's install button right here. So if you click on the packages tab, you hit install, it'll bring up this window. And there's various things. It says where to install it from, where to install it to, use the dependencies. These defaults are usually fine. It basically just, where do I pull it from, which folder does it go in, and if it needs me to install other packages, do I do so? The main part is you just need to tell it which package to install. So I'm going to do, if I start typing, I know there's one called car that has some useful functions. So I'm going to type car. You can see it pulls up a list of potential ones you want. So I'm going to say that's the one I want, car, and I'm going to install it. And so this is one part where RStudio makes your life easier because it handles a lot of the stuff with this behind the scenes, so you don't have to worry about the issues. So now there's going to be some stuff going on in here saying that it's going to be installing the R, etc. Excuse me. And this is going to take a few minutes because it turns out that the car package has a lot of dependencies it needs to get. So it will keep going this for a while. I'm actually going to stop this. And this is a tip. If R starts doing something and you don't want it to keep doing, press escape down here in the console. So you couldn't see it because I just typed in my keyboard, but here I click down here and I just hit escape. That tells R, stop what you're doing. And it will stop it as soon as it can. Sometimes it takes a few seconds to wrap up whatever it was right in the middle of and actually deal with the command. Usually it's very quick though. And so I will install the car package some other time because it looks like it's going to take a while. But once you have a package installed, and you can see other ones here that came either pre-installed or I've put on here, well, in order to use them, you need to bring them into into R. So it doesn't search everything all the time to know what's there. You need to tell it where to look. And so let's say I want to use the functions in this ggplot. So right now, I know one of those functions is called, one of those functions is called ggplot. It's the basic one. We'll talk about what this does in a few weeks. But if I try to run this right now, there's an error. It cannot find that function. I've downloaded it, but I have not told R to go looking for it and where to find it. And so it can't bring it in. So the way to get around that, the easiest way is over here in this window, I click on that button next to it. That little check mark then runs the function that loads it. And you'll see here, it puts something in the console, this library ggplot2. That's the other way of doing it. You can actually type in library, I don't know, let's use that one. And that is the command that will then load that library into the space, where now if I run ggplot, it runs. It doesn't do anything because of other stuff we'll talk about later, but the fact is I don't get that error anymore because now it knows where to find the ggplot function. Now it can run it. So this is how you load in these external libraries, these plugins, these packages, so that you can make use of what they have. When you do so, you have to know how to use them, and that brings us to help. So help is arguably one of the most important things to know about any programming language. It's how do you find out what you need? So in R, there are various ways to find help. The most straightforward is the help function, where you type in help and then you type in a function name. In this case, let's do ANOVA. If I run this, it runs help me. It's basically telling help me find help on the function ANOVA. And then over here on the help tab, it will bring up the help file for that function. That help file will talk about, they have pretty standard layouts. It will first give a very brief description of what this function does. It has some usage, which we'll talk about more probably next week as to what these various arguments and stuff are. Tells you the value you get back out, and then other various things like references, citations, examples, anyway, stuff like that. So you can access this using help. A shortcut is just a question mark before the function name too. We'll also do it for the same thing. Those are equivalent. Either one will work. Keeping with the theme of there's more than one way of doing stuff, RStudio also makes it. You see up here in the help window, there's this little search bar. And so we can search, let's search LM, that's linear regression. And you can see it pulls up all sorts of stuff. So that's the one I want. So I go searching for that. And it pulls up that help file. So this is very useful if you're using a function and you can't remember exactly what it's looking for, exactly what it gives back. It's good for those details. I'll be honest, it's actually not very good for telling you in plain English why you want to use that function. Most R documentation is actually written assuming you know what the function is supposed to do, and you just need to know how to do it. It's kind of the difference between like a recipe that tells you how to make a cake versus someone explaining why you would ever want to eat a cake in the first place. So R's help documentation is pretty good for the nuts and bolts of how do I get this function to work. If you want to know general stuff about why is this function useful, what is the big picture of what this function is supposed to do, your best bet is Google. So if you just type like the function and R, or usually even a plain language thing, how do I run ANOVA in R, and send that off into the ether, you will get a whole bunch of results that will tell you how to run whatever function is or what your thing is. Especially for common approaches like linear regression and ANOVAs and basic stats, there are tons of resources out there. There are YouTube videos, there are blogs, there are entire websites dedicated to teaching people how to use R because it's so widespread and so popular. If you start getting into more specific things like how do I use this particular statistical distribution in RNA-seq data, well, you're not going to get as many hits because there's many fewer people doing that, but you'll still get some. Odds are good that any question you have about R, at least a dozen people have had before, if not several hundred, and one of them has probably asked it somewhere. And so Google is a very good bet for trying to figure out how things work and how you should put stuff together. It sometimes takes a while to know the right terminology to use because, again, things like variables and assignments and vectors, these are words that describe stuff in R, and using that terminology will help people understand better what it is you're talking about because it just gives more precision. It may take a while to pick up on that terminology, however. That's just comes with time. Again, the more you practice, the more you read, the more you understand what it's talking about. So let's see. I think that's it. The last thing I want to mention is that you might run across a website called Stack Overflow. That's one of the most common places people ask questions about R. The answers you get there are generally trustworthy. Obviously, it's an internet forum, so the quality of answer depends on who's answering it. But there's some very good R users out there, and most of the answers I have seen on Stack Overflow have been pretty reliable. So if you run across an answer there, you can generally trust it. All right. That covers today. I'm going to stop recording just a bit, but before I do that, any general questions on the materials we have covered? Okay, so I'm going to stop recording